Okay, so today we have Unit 7, Lesson 6, and our focus is to graph ordered pairs and use them to represent and solve real-world problems. I didn't even finish that. Let's fix that. Real-world problems. Okay, so now we're going to look over here, just like we talked about, where we have, in Lesson 4, we wrote our number patterns horizontally from left to right. Here we're going to write them vertically up and down, like in this table. Okay, so for here, we put in 1 and we got to 5 because we added 4. So here we're going to do 2 and add 4 to that to get 6. 3, we're going to add 4 to that to get 7. 4, we're going to add 4 to get, and 5, we'll add 4 to get 9. Okay, now we're going to take that and turn it into the ordered pairs. So remember, your first number on the left becomes your x coordinate. The second number on the right becomes your y coordinate. So if you look at the example, 1, 5 is your ordered pair here. So our next one would be 2, 6, then 3, 7, then 4, 8, then 5, 9. Okay. Now we're going to take those and graph them on our coordinate plane. So we go over 1, up 5, because x comes first. Over 2, up 6. Over 3, up 7. You can probably point out a pattern at this point. And then it says to connect them, so we want to draw that connection line. Okay, so you can see that we drew a diagonal line with our coordinates based on this numerical pattern. So that numerical pattern created that line for us. Okay, so now let's look at what that would look like in a real world problem. It says, suppose a shrub grows at the rate excuse me, shown in the table below. Okay, so here's the age in years, and here's the height that it grows. Use the table to complete the exercise. Okay, so the first year, it's going to grow 0 feet because it's 0 years old, hasn't grown anything. It's funny they have this. How is it written in your book? Is it like mine or is it separated? Oh, how funny. Yeah, mine's written as 11, 22, 33, so it should be 1. Here, I'm going to cross these out. It should be 0, 1, 2, 3, 4, just like it's in your book like this. Okay, so it says write 5 ordered pairs that the data represent. Okay, so what are the 5 ordered pairs here? Okay, so again, just like in our first table, we're taking our first number, oops, and then our second number. So this is the x and this is the y. And now graph those on your coordinate plane. And as a scientist, if you were a scientist and you were studying the growth of the shrubs, you would be able to see once you graph your data that it grows at a consistent rate because there's that straight line. So every year it grows the same rate. Okay, so that's one way that we can use these for real world problems. Okay. A couple other options as far as real world connections here. Or if you turn the page, here they have it as a drippy faucet. How much water does a drippy faucet waste? Okay, so here's the time. Here's the amount of water. Okay, now this one, you have to complete the table. So if for 20 minutes, it drips 10 milliliters of water. So what's the connection between those? Looking at our numerical patterns, what's the connection between those? Vicki? Okay, so it's 10 less. Okay. What's another connection? It's half, right? Okay, so if 40 minutes, it's going to drip half of that, which is how much? 20. 60 minutes, half of that is 30. 0, half of that is 0. Okay, so once you fill that in, then you have your ordered pairs and you can graph. And you're going to see that straight line of your graph. Okay? Then it asks you to extend it to what would it be if it was 90 minutes? How much would it drip? What's half of 90? 45 milliliters. Here's another example. This is an automobile traveling. Okay, so how fast is an automobile traveling? Okay, so here, 0 minutes or 0 hours, it's gone 0 miles. Okay, but if it went for 1 hour, let's say this car is traveling at 60 miles per hour. So 1 hour would be what? 60. Do you see how I went over 1? 1 hour would be 60 miles. How long would it be for 2 hours? 120 miles. How far would it have traveled for 3? 180. And then how far would it have traveled in 5 hours? 300. Okay. So you can use that information to help you. So on your homework tonight for 7-6 on Think Central, you're going to have some function table or some numerical pattern tables that you'll fill in and graph. Some will have the graph like this and ask you questions about that graph. So you'll have to think about it in both directions. Okay? And that's all for today. We're just adding a few little extra real world applications.